This topic is about the Thevenin's and Norton theorem. This Thevenin and Norton theorem cover the circuit that containing only independent source, and then the circuit that containing independent and dependent source, and also we will learn about the maximum transfer power. The basic structure for this Thevenin and Norton theorem, where we have a linear two-terminal circuit and we have these two terminal A and B, where it's connected to this equipment load. Okay, so the objective is we want to simplify our circuit analysis, and we consider a linear circuit, for example, from a complex circuit with its two terminal that act as an output that may have several equipment load connected to it. So this is the equipment or load that connected to the terminal linear to terminal circuit. Okay, thus when the load are varies, so when these load are varies, all the variable voltage and current inside the linear circuit would also varies. So thus the analysis has to be done again. So this is a very tedious. Okay, the Thevenin theorem has been introduced in 1883 to solve this problem, where this Thevenin theorem is proposed by the M. Dion Thevenin in 1926. So the Thevenin theorem states that a linear two-terminal circuit could be replaced by an equivalent voltage source, which is a VTH or V open circuit, and an equivalent resistor or RTH, which connected in series. And then the equivalent circuit is looking between the terminal A and B. So this is a linear two-terminal, this is the terminal A and B, and then this is the equivalent Thevenin circuit. So we have the RTH here series with the VTH, and this is the terminal A and B. For the Norton theorem, this Norton is similar with the Thevenin theorem, where the Norton theorem states that a linear two-terminal circuit could be replaced by an equivalent current source, IN or I short circuit, and an equivalent resistor RN, which connected in parallel. Okay, so the equivalent circuit is looking between the terminal A and B. So this is a linear two-terminal. This is the terminal A and B. And then this is the equivalent Norton circuit, whereas this I Norton or I short circuit is in parallel with the resistor Rn. Okay, and then in this Thevenin and Norton theorem, you will learn about the source transformation, where a source transformation is a process replacing a voltage source VTH in series with the RTH by a current in 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 parallel with a resistor Rn or vice versa. So you can change this transformation. So this is the Thevenin circuit. You can change to this Norton equivalent circuit by using this source transformation. So in order to change from this Thevenin to Norton, so you can use this formula where I Norton is equal to this VTH, which is this one, divided by the RTH, which is this one, and for R Norton is equal to the R Thevenin. Same with the Norton's to Thevenin circuit, you can change by using this formula where the V Thevenin is equal with the I Norton or I short circuit times by the R Norton, and the R Norton is equal to the R Thevenin.